Alright, so we're going to continue with chapter P, section 2. We're going to simplify radicals and do some operations with radicals. So adding, subtracting, multiplying, dividing. This might be a longer video because I don't know, I'm recording this ahead of time, but I believe that you guys are going to have a quiz on part of this lesson, but not the whole thing. Right? The rest of this lesson is going to show up on your test. But I'm going to include everything in one video just so that you have one place to find it. Alright, so this is also a refresher from Algebra 1, right? So you should have seen radicals before, right? So, or like perfect squares, right? So maybe you've heard perfect squares before, right? Like 4, like 25, 36, right? And what's special about these numbers, right? You can write them as a product of a number times itself, right? So 4 is 2 times 2, 25 is 5 times 5, 36 is 6 times 6, right? And so, for example, the square root of 4, right? That's just asking what number do we need to multiply by itself to get 4, and that's 2, right? The square root of 4 is 2. Right, because when you square 2, you get 4, right? 2 times 2 is 4. Same thing with like 9, right? Square root of 9, you're asking what do you need to multiply by itself to get 9, right? And that's 3, right? Now, if it's not a perfect square, right? And you guys have probably seen this in geometry, right? You probably did it with Pythagorean theorem and whatnot. You could choose to do one of two ways to simplify a radical that's not a perfect square. Like, so 20, for example, that's not a perfect square. There's no whole number that when you multiply by itself, you get 20. The first method is to use a factor tree, right? So if you want to use a factor tree, like if you can't think of a perfect root off the top of your head, you would break down the radicands, right? So that's something I forgot to mention. In the first slide of this lesson, the title slide, you see a square root with an A and an N, right? The little number is the index, right? So if it's a square root, you don't see the index, right? But it's always going to be 2. And the big number that's underneath the radical is the radicand, right? So that's the number that you're square rooting. Now, to use the factor tree, you want to break it up into prime factors. If you remember a prime number, it only has factors of 1 in itself. And any pair that shows up any pair of factors that you get from doing this process is going to show up once outside of the radical. If you have multiple pairs, you would multiply them. And then if you have multiple factors that are remaining, you would multiply those underneath the radical. So I know a lot of talking, but for example, if I had the square root of 20, let's just say I want to break that up into 2 and 10, right? Hopefully you guys agree 2 times 10 is 20, right? 2, I can't break up 2 anymore, right? I could do 1 times 2, but 1 is a little redundant. We don't want to do that, right? But 10, I know I can break up 10 into 2 and 5. And then it looks like 2 I can't break up anymore, 5 I can't break up anymore. So this is my prime factorization, 2 times 2 times 5. Now, how many pairs do we have? Well, it looks like I have a 2 and a 2. That is a pair, right? And again, any pair shows up once outside the radical. So outside of the radical is going to be a 2. 5 is the lone factor that doesn't have any pairs, so that's going to remain underneath the radical, right? So my answer is going to be 2 square root of 5. But the other method, I think the more efficient method, if you know your perfect roots, is you extract them. Extract the perfect squares. So if the radicand has a factor that is a perfect square, extract the perfect square and simplify it. And you might have to do this a couple times until you get that there are no more perfect squares. But for example, 20, maybe you could see right away that 20 has factors of 4 and 5, and I already know that the square root of 4 is 2, right? This is already going to be 2, and then square root of 5, I can't break that down anymore. So my answer is 2 square root of 5. And you can see how just by knowing some perfect roots and looking for those factors, it makes it a lot faster than if you were to break it down entirely. All right, so we'll do some examples of simplifying. I'll try to do it both ways that you guys can see. All right, so I'm going to do some examples. We'll start with the first one, a square root of 28. Hopefully we can see that a square root of 28 is not a perfect square. There's no whole number that when you multiply by itself, you get 28. So we need to try to simplify it as much as we can. You can do it one of two ways. You can either do the factor tree or extract perfect roots. If you chose to do the factor tree, right, 28, the most obvious factors that most of you might look at first are 4 and 7. And then from here, hopefully you can see that 4 is a perfect square, right? If I square root 4 and square root 7, only 4 is going to get you the whole number of 2, right? Square root of 7 doesn't simplify anymore, so you leave that alone. All right, so square root of 28 is just 2 square root of 7. Maybe you didn't recognize that and you wanted to go further. Well, when you do 4, you get 2 and 2, and that is a pair, right? And that pair shows up once outside the radical. All right. Now, something like 48, a lot of you might not immediately see the biggest perfect square, right? And I'll tell you now, the biggest perfect square that's a factor is 16, right? 16 times 3 gets you 48. But a lot of you might not notice that right away. A lot of you might notice, I don't know, something like 4 and 12 first, right? Usually when I ask this in class, a lot of you give me these, or like 6 and 8 or something like that. 4 and 12, that's fine. And in this case, you also would see that 4 is a perfect square. So let's see if we can work with that, right? Square root of 4, square root of 12. Well, square root of 4, I know that this is 2. Square root of 12, does 12 have any other factors that maybe we could break it up into? It does, right? It has a 4 and a 3. So square root of 4, square root of 3. But square root of 4, I also know that that's 2. So I have a 2, and a square root of 3. So it looks like I have 2 whole number factors that showed up outside of the radical. If that happens, right, this is the same as saying 2 times the square root of 3. And I would just do my whole number times my whole number, which is 2 times 2, which is 4. So I get 4 square root of 3 as my answer for this one, right? It's easiest if you know the perfect roots that could be a factor, right? With 48, some of you might be able to see that this is the square root of 16 and the square root of 3, and that the square root of 16 is 4, and you can't simplify the square root of 3, so you immediately get 4 square root of 3. Or some of you might need to do a factor tree and split it up all the way, right? So maybe you did square root of 48, maybe you did, I don't know, 6 and 8, and then from 6 and 8 you did 2 and 3, and then from 8 you did 4 and 2, and from 4 you did 2 and 2. Then you have a 2 and a 2, which is one pair, a 2 and a 2, which is another pair, right? Any pair you multiply if there are multiple. And then 3 is the only lonely factor that stays inside the radical. And you see that no matter what way you do it, you get the same answer of 4 square root of 3. All right, so hopefully that makes a little bit more sense. All right, and so this next one, 2 square root of 48, the only difference here is that there's a factor in front, right? Now, same exact process as before. Some people like to try to, I don't know, do the whole number with the radical, so maybe do 2 times 48 and multiply them together. You shouldn't do that, right? You can never multiply a whole number with a radical other than just leaving it the way it is. All right. Now, square root of 48, lucky for us, we already found this before in example number 2, right? We know that that's 4 square root of 3. So I know that this is 4 square root of 3. If I didn't know that, I would just simplify it as normal, right? So, and then I have a 2 in front. This 2 is a factor, so it's going to be 2 times 4 times the square root of 3, right? Whole number with the whole number is going to get us 8 square root of 3. All right. So same process as before. If you have a factor in front, just multiply it. right? And then what about 6 square root of 45? Okay, well, we can still try splitting up 45 into either prime factors or extract perfect roots. If you think about what multiplies to 45, hopefully a lot of you recognize that 9 and 5 get you 45. And one of these, lucky for us, is a perfect square, right? The square root of 9 is 3, and the square root of 5 is just the square root of 5. All right, so the square root of 45 is going to get you 3 square root of 5, but don't forget we have a 6 out front as another factor, so it's going to be 6 times 3 square root of 5. And then when you go to multiply these together, it's going to get you 18 square root of 5. All right, so these are your your simplifying examples. All right, so hopefully pretty simple. All right, now with multiplying radicals, let's say I had one radical times another radical. If the index is the same, you can multiply under the same radical. Right, so for example, a square root of 2 times a square root of 3, you're allowed to say that this is the square root of 2 times 3, and 2 times 3 is just 6, right? So we say that this is the square root of 6. And something major here is that this is only true if the index is the same. So for example, if I had a cube root of 2 times the square root of 3, remember I mentioned it before, but the index is the number, this little number, right? And then if you don't see it, you assume it's a 2, right? This one has an index of 3, this one has an index of 2. You cannot multiply these, right? So you just leave it alone like that. If you have specifically square roots, right? So meaning if you have a radical with an index of 2, right? Or no index. So for square roots, if the radicand is the same, remember the radicand is the number inside. If the radicand is the same, the answer is the radicand as a whole number, right? So if I have a radical 3 times a radical 3, right, this radicand matches, and it's a square root, it's just going to be that number outside of the radical. All right, and that's always going to be the case. You could do what we did up here and do the square root of 3 times 3, which is the square root of 9, but hopefully from here you recognize that the square root of 9 is just 3. All right, so just some things to make the math in future problems easier. All right, so let's try some examples. Once again, whole number times the whole number. In this case, the whole number is 5 and 2. I would do 5 times 2, which is 10. And I can do the square root with the square root, right? Radical with the radical. 2 times 3 is going to get you 6, right? And they're both under the radical. It's going to stay under the radical. My answer is just going to be 10 square root of 6. All right. Now, with the square root of 11 times 33, if I were to do 11 times 33, that's going to get you a really big number. So what I like to do if I see that is you should be checking if you can rewrite one of these radicands to have a factor of the other, right? So if I see an 11 here, let's just say I want to break up 33. I recognize that 33 is the same as the square root of 11 and the square root of 3. Right, now if I was just simplifying the square root of 33, that wouldn't help me that much. But because I have this square root of 11 right here that I'm also multiplying with, right, what did we say about the same radicand twice, right? 11 and 11 is going to show up once. That's your answer as a whole number, right? So the radical goes away. And then 3 is the lonely factor that doesn't have any matching pairs, so we just leave it alone under the radical, right? So your answer here is just 11 square root of 3. All right. And now with the next one, right, square root of 5 and square root of 5 are not, these are not perfect squares, but once again, I have the same radicand and it's a square root, right? My index is 2, if you don't see it. So then this is just going to be 5, right? Same radicand twice, multiplying just shows up once outside the radical. All right, and then square root of 9, hopefully you guys can recognize that right away, that's 3. So this is just 5 times 3, which is 15. all right? Same exact thing with something like this, all right? Square root of 25, hopefully you guys can recognize that that's 5 right away. And then the square root of 45, well, I can't really find a perfect root for that, so I'm going to split it up into factors and I'm going to try to simplify it as much as I can. And this is going to get you square root of 9 and square root of 5. And the square root of 9 is 3. I can't simplify the square root of 5 anymore. Don't forget we had this 5 out front, so it's going to be 5 times 3 square root of 5. 5 times 3 is going to get you 15, so I get 15 square root of 5 as my final answer. All right, so hopefully not too bad. Now when you're adding and subtracting, right, you need the index and the radicand to be the same. Now, if this is the case, you can add and subtract radical expressions. You can treat the radical as a variable, and you can combine like terms. Sometimes you need to simplify the radical first to get your like terms, or I guess your like radicals, right? But some examples are something like this, right? 2 square root of 5 plus 4 square root of 5. If I have a square root of 5 and another square root of 5 and there's a plus in between it, right? Treat it like if it was a variable, right? The 2 and the 4 are the whole numbers out front, or are coefficients, and 2 plus 4 is just going to get you 6. Don't do anything under the radicand. Under the radical. All right, the radicand is going to stay exactly the same. Treat it like a variable, right? That's usually what helps some people visualize it a little more. Let's say I had 2x plus 4x, right? We'll get to polynomials in chapter P.2c, but hopefully you can see that these are like terms, right? 2 plus 4 is going to get you 6, and then you leave the x the same, right? These are just like terms, right? So your variable here would be 5, right? Something like the next one, 2 square root of 24 plus 4 square root of 6, I'm going to have to simplify one of these to get it to look like the other, right? You might see 24 and 6 don't match, but that doesn't mean you can't add them, right? You might just need to simplify a little bit before you do, right? And the square root of 24, I can split that up into the square root of 4 and the square root of 6, and I know that the square root of 4 is 2 square root of 6, right? And then this 2 and this 2 out front are going to multiply, and this is going to be 2 times 2 square root of 6, right, plus 4 square root of 6. And then this is going to be 4, right? So this is going to be 4 square root of 6 plus 4 square root of 6, all right? And because now they have the same radical expression, right, you just add the numbers in front as if it were coefficients, right? So 4 plus 4 is going to get you 8. So I get 8 square root of 6, all right? Again, if it's confusing, think of it like a variable. If I had a 4y plus a 4y, right? Don't do anything into the variable, just add the coefficients, 8y, something like that. All right. And then something like this one, 2 square root of 2 plus 2 square root of 3. Well, 2 and 3 can't really simplify any further, right? They don't match. You can't really get them to match, so you just leave it like this, right? That's kind of tricky at first for some people. If they are not used to that, you don't have to do anything to that, right? Again, treat these radicals like variables. If I had a 2x plus a 2y, could I add those together? Right? No, right? You just leave them alone. They're not like terms, right? Exact same thing here. They're not like radicals. So you just leave it alone. All right, so we're doing some examples, right? Some of these look a little bit easier than the others. This first one should be pretty easy, right? I see a square root of 3 and a square root of 3. All I have to do is combine the numbers in front. Right, so it's 8 and a minus 6. 8 minus 6 is 2. Don't do anything to the radical, right? Treat it like a variable. It's just going to be 2 square root of 3. All right, simple as that. With this next one, square root of 24 doesn't match square root of 6. It looks like we can take the bigger one and break it up to be the smaller one. All right, and this is going to be the square root of 4 and the square root of 6. The square root of 4 is 2, so I get 2 square root of 6. Don't forget there's a negative 2 out front, so it's negative 2 times 2 square root of 6. And then there's this whole expression on the outside, minus 3 square root of 6. And then negative 2 times 2 is going to get you a negative 4 square root of 6, minus 3 square root of 6. And now they match, right? The radicands match. right? So I have a negative 4 minus 3 is going to get you negative 7 square root of 6. All right, and then that's fully simplified. All right, now if you look at something like this next one, well, the radicands don't match 5 and 3, and it doesn't look like I can break up 5 and 3 anymore, right? 5, the only other way that I could write that is just 5 times 1, right? And anything times 1, you don't really want to do anything with that. So that's it, right? Super easy. You don't have to do anything with that, right? Just that by itself is your answer. You only add or subtract when the radicands are exactly the same, right? Some people are tempted to do stuff under the radicands, right? So you might do 5 minus 6, so negative 1, and then 5 minus 3 square root of 2. Absolutely not. No, that is very, very wrong. You need to make sure that the radicands are the same. You can't do anything like that. All right, common mistake that I see. All right, next one. I have the square root of 28 minus square root of 63. Well, looks like nothing matches here, right? So what we can do, try to simplify it before giving up, right? So square root of 28, we did this a couple of times. This is the square root of 4 and the square root of 7. And it looks like 63 is the square root of 9 and square root of 7. Right, so it looks like square root of 4 is going to get you 2 square root of 7. And then this is going to get you 3 square root of 7. Right, there's a minus in between it, so we're subtracting. And now it looks like our radicands match, right? A 7 and a 7. Again, treat it like a variable, and we do 2 minus 3, which is negative 1 square root of 7. All right, if your coefficient is 1, you don't have to write the 1. So you can just leave it as negative square root of 7, or you can write the 1. I'm not super picky in that sense. All right, so just doing some more examples. I'm going to kind of combine all of the skills that we just went over, right? So multiplying, dividing. Multiplying, adding, subtracting into some kind of more complicated expressions. Right, so this first one, I have the square root of 5 times the square root of 5 minus 2, right? Again, just like with any other number, as long as it's out front of parentheses, it's being multiplied and you can distribute, right? Square root of 5 times the square root of 5, well, it's the same radicand, same index, it's just going to show up once, right? So then that's going to get you 5. And then if I have the square root of 5 times negative 2, it's just going to be negative 2 square root of 5. Right? Treat it as if it had a 1 in front. I can only do the whole number with the whole number, and there's no radical to go with this radical, right? So it's just 1 times negative 2, so negative 2, and then square root of 5. Doesn't match with anything. Again, treat it like a variable, if that ever helps, right? And that's all you have to do with that one. All right, this next one, it looks like I have a binomial times a binomial, right? A binomial is just 2 terms. And if you remember these, what you have to do is FOIL, right? And we'll do more foiling in chapter P.3, but hopefully you remember this from Algebra 1. We can do our first, outer, right, inner, and last. All right, so just doing that is going to get you square root of 4. Not square root. 4 times 4, so 16. Right, outer times the outer is going to be 4 times negative square root of 11. Right, can't multiply a whole with a radical, so it's just going to be negative 4 square root of 11. Right, leave it just like that. And then inner times the inner is going to be square root of 11 times positive 4 is going to be 4 square root of 11. Again, I can't do a whole number with a radical, so you just leave it like that. And then square root of 11 times square root of 11, right, last times last, is going to be minus, right, because positive times negative. And again, exact same radicand, so it's just going to be 11, right, whole number 11. And now we want to combine like terms, right? So it looks like I have a whole number with a whole number, so 6 and negative 11 combine. 6 minus 11 is going to get you 5. And then it looks like I have a square root of 11 and a square root of 11, so I combine the numbers in front. Negative 4 and positive 4 gets you 0. So these cancel out and you just get a whole number 5. This example is pretty important because it's going to show up a lot when you divide exponents, right? You're going to have to create that pair that gets you a whole number. Even though you have two radical expressions, you multiply them and you got a whole number with no more radical. All right, that's important for dividing when you want to simplify radical expressions that have a radical in the denominator. All right, that's different from this one because if you remember, the square of a binomial, you're going to have to actually write it twice and FOIL it. Right, so it's going to be 3 square root of 7 minus 5 times 3 square root of 7 minus 5. And you can do the same thing, right? First times first. It's going to be 3 times 3, which is 9. And square root of 7 and square root of 7, which is just 7. And I made a mistake. This is square root of 5. Right? That would have messed up the next step. But okay, so we can do outer times the outer. So 3, there's nothing to multiply with the 3. So it's just going to be, right, it's negative. So it's going to be negative 3. And then I have a square root of 7 and a square root of 5 is going to get you square root of 35. Right? If they're both under the same radical, then you can multiply them. All right? And then it's inner times the inner. So negative square root of 5 times 3 square root of 7 is going to get you negative 3 square root of 35. Right? Because 5 times 7, they're both under the radical. 3 is my whole number, nothing multiplies with that. And then I do my last times my last, right? So negative square root of 5 and negative square root of 5. Negative times negative is positive. And then if I have the exact same thing, it just shows up outside of the radical. All right? And then here when I go to combine like terms, right? 9 times 7 is 63. These have the exact same radical, right? 35 and 35. This time they don't cancel out. Negative 3 and negative 3 is just negative 6 square root of 35. All right, so some people make the mistake of just crossing it out. They're the same. You have to combine like terms, and they don't cancel out. All right, and then there's a plus 5. So I can do the whole number with the whole number. All right, so 63 plus 5 is going to get you 68. So I get 68 minus 6 square root of 35. All right, so I get something like that. Right, requires a little bit more steps, right? That's why these are kind of combining everything. But hopefully the steps are doable and you can understand them, right? So next one, again, you're just distributing. This isn't a binomial or anything, so you don't have to FOIL. So it's just going to be whole number times a whole number. So 3 times 4, 12. And then a square root of 6, square root of 6. It shows up once outside the radical, so it's just 6. All right, and then it's plus 3 times nothing, right? So it's just going to be 3. That's the only whole number. And then the radical is multiplying with the radical. So 6 times 3 is 18, so square root of 18. And then check if you can simplify this, right? Some of these you can. 12 times 6 is 72, plus 3, and then square root of 18 is 9 and 2. And then this 9 becomes a 3. So then I get a 72 plus 3 times 3, which is 9, square root of 2, that doesn't simplify. So this is your final answer. Right, so they kind of combine all the steps that you need to simplify more complex expressions. All right, now lastly, we can divide radicals. So if the index is the same, you can divide under the same radical. If you have a radical in the denominator, it is not simplified, and you need to rationalize the denominator. And that process, you're going to multiply the top and the bottom by the radical in the denominator. Unless you have a binomial, meaning you have two terms. Right? You're going to multiply the top and the bottom by the opposite expression. Or you might hear me say it's called the conjugate, right? So the same expression, just opposite sign. I'll show you what that means in these examples. All right, so square root of 10 and square root of 5, right? It's the same index, and they're being divided, so this you're allowed to write them under the same radical. right? And then you can just divide as normal. 10 divided by 5 is 2. So it just looks something like that. Similarly, guys, if I gave you something like that, you wouldn't ever do this, but, well, no, sometimes you will do it, but for something like 10 and 5, you would just simplify that. But sometimes it makes sense to split it up, right? So 10 and 5, you're also allowed to go backwards and do it like that, right? That's allowed also. That might be helpful in future lessons, right? Just so you know this. Okay, but if I have something like 2 over the square root of 5, right? Only the bottom is a radical. So what I have to do in that case is I'm going to multiply the top and the bottom by that radical, right? You guys probably saw this or did this in geometry. But you're going to multiply the top and the bottom by that radical to rationalize the denominator, right? You want to make the denominator a real, like a whole number or an integer of some sort, right? So on the top, 2 times square root of 5 is just 2 square root of 5. And then square root of 5 and square root of 5, that becomes a positive 5 with no radical, right? And so our denominator is rational now, all right? Now, if I have something like this, 1 over 2 plus square root of 5, if I try just multiplying by the square root of 5, you're still going to end up with a radical in front of this 2. So what you do is you multiply by the conjugate. Now, the conjugate is the exact same terms, it just has the opposite sign. All right, similarly, if it was a minus, then you would multiply it by a plus, right? But here it's a plus already, so I'm going to multiply the top and the bottom by 2 minus square root of 5. And then the top, you can just multiply the top however you can. 1 times 2 square root of 5, or 2 minus square root of 5, you can just distribute that, and that's just going to end up with 2 minus square root of 5. And the shortcut for multiplying by the conjugate is you can square the first minus square the second, right? So instead of foiling and then canceling out the middle terms, I can just do 2 squared minus square root of 5 squared. But square root of 5 squared, square roots and squares are opposites, so I can cancel those out. And then this is going to get me 2 minus the square root of 5 over 4 minus 5. And then 4 minus 5 is negative 1. So this is 2 minus the square root of 5 over negative 1. And you can actually simplify this a little more, right? So that negative 1 is going to make this 2 over negative 1 minus square root of 5 over negative 1. That's going to get you a negative 2 plus square root of 5. Right, so dividing gets a little complicated at some point. There's a lot of steps that you need to do to make sure that your answer is fully simplified, right? But go through the same steps. It's gonna get easier as you do more of them, right? But I know it's a lot of steps. All right, so I'll show you with this first one. You could start by multiplying the top and the bottom by the square root of 35. But notice that I have a radical on the top as well. If I have a radical on the top and the bottom, you can simplify inside of those radicals. 7 and 35 gets you a 1 and a 5, right? They share a factor of 7. And then square root of 1, that's just 1, right? And anything times 1 is itself. So I'm just going to get rid of that entirely. So this is going to be 6 over the square root of 5. And now I can multiply the top and the bottom by the square root of 5. All right, so then I get 6 square root of 5 over 5. All right, and then the denominator is rational. All right. Now for something like this, it doesn't make sense for us to put it under the same radical, all right, just because 2 and 3 don't simplify. So you can immediately start by just multiplying the top and the bottom by the denominator, right? So then 7 times square root of 2 times square root of 3, square root of 3 and square root of 2 and square root of 3 is going to get you square root of 6. And then square root of 3 and square root of 3 is just 3. And then the denominator is rational, so that's simplified. Again, you never want a radical in the denominator. All right, so now let's try something like this, right? Now, if there's a plus or a minus in between, you need to multiply by the opposite expression, right, or the conjugate. In this case, it's going to be 3 minus the square root of 2. So I'm going to do that on the top and on the bottom, right? Whatever you do to the top, you have to do to the bottom, and vice versa. And on the top, this is as simple as just distributing that 1. And that's just going to be a 3 minus the square root of 2. And then again, on the bottom, use the shortcut. You don't want to FOIL every single time and then cancel out the terms, especially with all these radicals. So it's just going to be the first one squared minus the second one squared. All right, and then this is going to get you 3 minus the square root of 2 over 9 minus 2. Right, square root of a squared cancels out. And then 9 minus 2 is just 7, so I get 3 minus the square root of 2 over 7. 7 doesn't go into 3 or whatever coefficients in front of this one, so we can just leave it alone. All right, and that's all we have to do for that one, right? So some of these are simpler than others. Something like this one's going to require a little bit more work, but same exact process and steps as always, right? So on the bottom, I do have two terms, a whole number and a radical number. So what I'm going to do is I'm going to multiply the top and the bottom by the opposite expression, right? If I see a 1 minus square root of 2, I'm going to do a 1 plus the square root of 2 on the top and on the bottom. All right. And when I go to do that, on the top, it looks like I have a binomial and a binomial. I'm going to have to FOIL, right? So when you FOIL, you might get a big expression. That's fine, right? So it's going to be first times first, so 3 times 1. Outer times outer, so 3 times square root of 2. Square root of 2 times 1, right? Inner times inner. It's just 1 square root of 2. And then square root of 2 times square root of 2 is just going to show up once outside the radical, so just 2. And on the bottom, use the shortcut, right? 1 squared minus square root of 2 squared. All right. And so on the top, it looks like we can simplify. 3 plus 2 is going to get you 5. 3 square root of 2 and 1 square root of 2 is going to get you 4 square root of 2. All right. And on the bottom, 1 squared is 1. Square root of 2 squared is 2. 1 minus 2 is negative 1. When there's a negative 1, you do want to simplify it, or you don't want to just leave it like this, right? That negative 1, all you have to do when you see when you're multiplying or dividing by a negative 1 is change the sign of everything, right? So it's just going to be negative 5 minus 4 square root of 2. If you're not comfortable with that, if you're dividing by the same denominator, then you can just divide both terms on top by that denominator. All right, and then you still get the same answer. All right, and that's as complicated as it might get, or you might see some crazy expressions, but for the most part, that's it for this lesson. All right, and then we're going to relate this to exponents in the next lesson after this. Right, and then you're going to have to simplify some higher roots, right? So cube roots, fourth roots, and things like that in the next section.